Flying at Mach 6 speed could soon be very possible thanks to this. Founded with the goal of developing hypersonic aircraft capable of transporting passengers around the world in record time, Venus Aerospace is pushing the boundaries of what is possible in aviation. The goal is to develop vehicles capable of traveling at speeds in excess of Mach 5 or 5 times the speed of sound by committing to incorporate sustainable practices and technologies into their designs, reducing the environmental impact of high-speed travel without having to detract one iota from passenger safety or comfort. Now, the company has just introduced its innovative engine, the Venus Detonation Ramjet 2,000 pounds thrust engine, VDR2, in an exciting development for high-speed aviation. This system is not only valid for airplanes, but also drones and other types of aircraft that will be able to travel at high speed with incredible efficiency. The VDR2 integrates the powerful thrust and efficiency of the rotary detonation rocket engine, RDRE, with the high cruise efficiency of a stator jet. This unique engine provides propulsion from liftoff to speeds of Mach 6 with an airflow design that minimizes drag and eliminates the need for complex mechanical components. It is somewhat like a jet engine, although it is essentially a stator jet, where the incoming air is compressed by the speed of the engine moving forward rather than by the turbine blades spinning, as in a conventional jet engine. The engine can maintain continuous thrust at extreme speeds, something that sets it apart from existing hypersonic systems that rely on glide bodies that are launched at high altitudes, which is really impractical for commercial aircraft that clearly need to maintain powered flight for the entire trip rather than a specific leg. How does it work? This technology increases both thrust and efficiency through a constant detonation process. During this process, fuel and oxidizer are introduced into a confined space between two cylinders and ignited, generating a supersonic shockwave that rotates within the space. This method generates significantly more power than traditional combustion methods. The result is a low aerodynamic drag engine being developed in collaboration with Tecnology and based on an earlier Venus Aerospace project. With all its features, the new engine is capable of reaching altitudes of 52,000 meters in continuous thrust at speeds up to Mach 6, which refers to 6 times the speed of sound in air, being approximately 7,410 kilometers per hour under standard conditions. Mach 1 is generally considered to be approximately 1,235 kilometers per hour at sea level and at a temperature of 20 degrees Celsius. The engine is 15% more efficient than conventional engines if Venus Aerospace meets its current design goals. When will it make a test flight? The VDR2's maiden test flight is scheduled for next year, 2025, and if all goes according to plan, this development will have an incredibly large impact on future hypersonic aircraft. It could revolutionize the entire air travel scene. A stator jet is ideal for hypersonic flight because it can withstand much higher temperatures than a traditional engine. This is due to its simple design and the absence of moving parts. This feature is crucial because at hypersonic speeds, the air entering the engine can heat the interior to an impressive 2,130 degrees Celsius, which, as is easy to imagine, would quickly melt turbine blades or similar parts in a conventional engine. Venus Aerospace, founded in 2020 by Andrew and Sassy Duggleby, is a venture capital-backed startup that has raised $70 million to develop this type of technology that will revolutionize the world of aviation. So far, they have successfully flown their supersonic drone, something that happened in February 2024. We will have to see the results of next year's tests.